All right, join me on page 287 of the Go Math textbook, the big book. Let's follow along. All right, we're going to be talking about like terms. Like terms are terms that have the same variables with the same exponents. Numerical terms are also like terms. Okay. So here's some examples. Here's an algebraic expression, 5x plus 3y minus 2x. So you see the 5x and the 2x, they both have the same variable and they both have the same exponent, which in this case is just 1. So these two are like terms. Okay, notice terms, again, our vocabulary are separated by a plus sign or a minus sign. So these are all the terms, and 5x and 2x both have the same variable x. So those are considered like terms. Okay, look at the next example. 8z squared plus 4z plus 12z squared. So again, terms are separated by plus or minus signs. So here are the terms. And the only ones, see, 4z has z as its variable, but it has a different exponent. So it is not considered a like term with 8z squared and 12z squared. These are the only like terms because they have the same variable and the same exponent. Same variable and the same exponent. Okay, here, 15 minus 3x plus 5. Again, terms are separated by plus signs and minus signs, so our terms are 15, 3x, and 5. And numerical terms are also like terms. So 15 and 5 have no variable and no exponent, so they are just numbers by themselves. That's what it means by numerical terms, terms that are numbers by themselves with no variable. They would also be considered like terms. Okay, if you need to rewind and listen to that again, please do so, because this is an important fact for today's lesson and moving forward in math. All right, let's take a look at our problem and how we're going to use combining like terms to help us solve problems. Baseball caps cost $9. Patches cost $4. Shipping is $8 per order. So we could write the expression 9n plus 4n plus 8, and that would give the cost in dollars of buying caps with patches in players, meaning however many players we had on our team that year, we could figure out the cost based on how many players we end up with. Simplify the expression by combining like terms. Okay, so simplify means break it down by doing what? Combining those like terms. Okay, so I need to simplify the expression, and they gave us the expression. It's right here. So I need to simplify the expression 9n plus 4n plus 8. What information do I need to use? I need to use the like terms of 9n. Remember, going back up to our definition, terms have the same variables with the same exponent. So the other number in this expression that has the same variable n with the same exponent, meaning there is no exponent, would be 4n. So those two both have the same variable, n. I can use a bar model to find the sum of the like terms. Okay, draw a bar model to add our 9n and our 4n. Each square represents n, or just one n. So here we have 9 n's, here we have 4 n's. And since they're all n's, we can just add them all up. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 n's. We have 13 n's total. So the model shows 9n plus 4n is 13n. So we can rewrite this 9n plus 4n plus 8 as just 13n plus 8. because 9n's plus 4n's equals 13n's. Okay. The variables stay the same. We're just adding the numbers that you're multiplying by. Now, let me show you really quickly why this is acceptable. Okay, let's plug in a number for n, and I'll show you how it works. Let's plug in 2 for n. So if I do 9 times 2, that equals 18, and I do 4 times 2, because 4n would be 4 times 2, that equals 8. So my total is going to be, what, 1626? Now, let me show you what happens when we combine terms. If I do 13n, or 13 times 2, I also get 26. So that's why it's okay to do that in math, because you're not changing the value of the answer. You're not changing what the answer is. You're just simplifying it to do, instead of doing 2 multiplication problems, you're just doing the 1. That's all combining like terms is doing. It's just making you have less math problems to solve. Okay? Just simplifying the problem. So again, this is why it works and why it's acceptable to do that, to combine like terms. All right, thanks for watching. I'll see you on the next one.